Hello. Today I'm going to guide you through the first quiz. So I tried to uh, make it a smooth conversion from Blackboard to Brightspace, but as I expected, as you already got some emails, I made some mistakes. So and some questions may look a little bit weird, but it's not easy to fix that automatically. So, but not a big problem in doing the homework. So when you want to do the quiz on Brightspace, you may either do it on content, and you should be able to see this, or you can click quizzes, and the same quiz is available here. So let me try this. So I like you can just click the quiz and start. Nothing special. Oh, by the way, I already tried myself. So you can try the quiz up to 10 times. And I completed one of them. So now you have 9 more times. In this case, I have 9 more times, and there is no time limit. So when you open the quiz, you have unlimited time until you submit it. And the due date is September 17th. By the way, it is 11:59. So it is not exactly 12 o'clock. So because 12 o'clock is recognized as September 18th, which may cause more confusion if I set the due date as September 18th. So just literally don't submit in the last minute. I have seen a student who missed the due date just because by 1 minute, just by 1 minute. So the due date is September 17th, and as I said in the syllabus and the introduction, I will give you 1 week grace period after this due date. So keep that in mind. It is your responsibility. It is your responsibility to finish everything on time. Okay, let's start. Let's see how you do it. How we can do it. So when you press start quiz, you are going to see many, like 10 quizzes, 10 questions, but each time the order is randomized and the numbers are randomized, questions are randomized. So you are going to see different questions from what I'm going to do now here. I made a slide for the quiz guide, but your question may have a different number. But still, this guide must be helpful to you. So let me try. So this is, by the way, I'm going to skip the simple like definition questions, right? I will guide you through the numerical questions only. But as I said, your numbers will be different. And even though I get this question at question number 2, but you may have different order. So you will have the similar question with different numbers, but it could be question 10 or question 1. So you have to understand that. So if you need help, help for a specific question, you have to search the video where I do that. Okay. So in this question, this example is about smartphone and carrier. So I assume that there are 3 types of smartphone makers: Apple, Samsung, LG. By the way, LG LG closes its business, so I have to update this question. And 3 carriers, only 3 carriers: Verizon, AT&T, and T-Mobile. And in this example, I ask you, there is an app that is on discount on Labor Day for T-Mobile users, but it is not available on Apple. So then what is the probability of smartphone users who can use this discount? So then, like it's a simple question. First, you have to understand that to take advantage of this discount, you should be T-Mobile user and you should not use Apple. You should not be Apple smartphone user. So basically, there are two conditions: T-Mobile and non-Apple. Their two conditions should be satisfied at the same time. So mathematically, that is connected by this cap intersection. And so T-Mobile user and non-Apple, Apple complement. So superscript C stands for complement set. So anyhow, it doesn't matter whether you can use this notation or not. What you have to do is you have to find out, there are 9 types of smartphone users, but you have to find out which types satisfy those conditions. Easy, T-Mobile users and non-Apple users. So there are only 2 types. And once you identify these 2 types are included in this event, then we can easily see that the probability is 30%. So as I said, your answer, your option, your choices will be different, may be different. If you're lucky, you will get the same numbers, but your numbers may be different, so it's up to you to find your own answer. Okay, I'm just explaining what you have to do here. Okay, next question. Oh, this is a more complicated question. It's about GMAT and GPA data. So, given the data, simple data, we would like to fill this probability distribution table, right? We would like to summarize the data into 2x2 probability distribution table by hand, unfortunately. So it's also pretty easy. We are going to classify GMAT into higher than 600 or not, and GPA as higher than 9 or not. So what you have to do is you have to count how many in each type. So this is counting. I circled the observations that satisfy each of the criteria. So higher than 600, 1, 2, 3, 4, 5, and higher than 9, 1, 2, 3, 4, 5, 6. By the way, it is not just simple counting. You have to classify these observations into 4 types. So for the first entry, top left entry, you have to count the number of observations that satisfy both conditions. There are 1, 2, 3 observations coming into this entry out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the total number of observations is 10. Out of 10, you have 3 observations satisfying this type, right? So probability should be 30%, 3 out of 10. Similarly, here, in this entry, top right entry, GPA must be greater than 9, but GMAT lower than 600. So let's count 1. So that means you should circle only on the right column, sorry. So 1, 2, 3. There are also 3 observations here, so 30%. 3 out of 10, 30%. And here, 1, 2. So 2 observations. And for the last one, non-circled, 1, 2, 20%. So 30, 30, 20, 20%. That is how you summarize these observations. Okay, next question. Here, the question is simple. A survey of magazine subscribers indicates that 35% own a house, 80% own a car, and 30% own both. What is the probability of the subscribers who own a car but not a house? Okay. Here, what we basically want to do is we'd like to recover this 2x2 probability distribution table. So I put unknowns x, y, z, w in each entry. And I will now, based on these unknowns, I'm going to relate these unknowns to our information. So, like this. First, 35% own a house. 35% own a house, which includes X and Z. So own a house house owners include these 2 types. And 80% own a car. So car owners include x and y. So 80% equals x plus y, right? And 30% own both, which is x. So 30% is only this type because they own both of house and car. So it makes the problem easy. We know x equals 30%. So by comparing x plus z with x, then you can see that z is only 5%. So x plus y is 80%, but x is 30%. Easily, you can find y is 50%. So of course, x is 30%. If you want to find out w, you have to utilize this information. Sum of all unknowns must be 100%. But we know x plus y plus z is 85%. So as a result, w should be 15%. But what you need is the probability is, the question asks you, what is the probability of own a car but not a house? Own a car but not a house. So that is y. So it asks you to find y. We already found it here. So the answer is 50%. Okay. So it is like linear solving a system of linear equations. I believe you should be able to do that. And your numbers, of course, your numbers may be different. So be careful when you solve for these unknowns. Okay, next one. So the question is about hobby shop record, but actually the sentence doesn't mean a lot. Like basically it records the number of trucks, like say number of toy trucks sold, so number of weeks. So in the past 50 weeks, 20 of them did not sell any toy trucks, any RC trucks, right? But there was a week, maybe holiday week. In that week, 4 toy trucks were sold. So in that way, the sales records are summarized. It's so, and I'm like, you have to calculate the probability of selling at least 2 trucks, at 2 or 3 or 4, at least 2. So it sounds a little complicated, but basically, if you rename them as outcome, there are 5 outcomes, 5 possible outcomes, and frequencies, number of occurrence, right? So if you try this random experiment 50 times, right? Random experiment is counting how many trucks are sold. So in 50 repetitions, 20 times you get 0. 1 time you got 4. So in that sense, basically it is frequency table. And from the frequency distribution table, you would like to calculate probability of this event. Event that includes 3 possible outcomes, right? 2 or 3 or 4. So out of the total number of observations, 50, out of 50, out of 50, 15 times you satisfy this event. You sold at least 2 trucks. So in that sense, 15 out of 50 is the probability. Okay? So like the point of this question is to understand this column stands for outcome and this column stands for frequencies. So I just described what is the outcome, what's the frequency in casual words, but statistically pretty simple problem. Here, the next question is about accident and auto insurance. Like also it has many sentences before and after, but the main point is here. So auto insurance company classifies car accidents that involve alcohol or at least 3 vehicles as severe accidents. So we defined an event called severe accident in this way. The event defined as severe is either alcohol or 3 vehicles, at least 3 vehicles. So in the end, what is the probability of severe accidents? Okay, so what is the probability of this event? In our mathematical notation, you can write it as probability of alcohol or 3 or more. So you connect them with or. So or is the connection. So you have to include all these types of accidents which involve alcohol, right? And also you have to include these types of accidents which involve at least 3 vehicles, right? Right? So in general, we would to calculate this probability of event, we need to count the outcomes in the event, divide that by the total number of events, total number of observations, right? So first, in the denominator, the total number is sum of these 6 numbers, which is maybe, I don't know, you count it, and the event severe accidents include one, two, three, 4 types. So include that in the numerator. That is the probability. So as I said, again and again, your numbers may be different. So yeah, algebra is yours. It's not that difficult. Next question. It's too simple. In this 2 by 2 probability table, we consider whether a person buys milk or not, buys beer or not. Okay, the probability is given this way, and we would like to calculate the probability of buying milk or buying beer. So it is connected by union of M and B, M cup B. So then also pretty simple. In principle, you can just count, you can check the types of buyers, types of customers who satisfy this event. So in this, to satisfy this event, to be included in this event, a customer should buy either milk or beer. So if buys one of them, that's enough. So it includes 1, 2, 3 types. The other type, those who do not buy neither milk nor beer, is excluded. Okay, so basically this event includes 3 types, so you can calculate probability this way. Pretty simple. Or if you wanted to use some formula, you may do this, but it is not efficient here because anyhow you have to recalculate this probability by adding these two, and this calculate probability by adding these two, and subtract another probability like that. But basically the same process. You would like to add 3 types just once. So both are correct, but it's not a good use of the addition rule. I'm just telling you because some of you may think they need to use formula, but you don't need to. Okay. Maybe this is the final question. So this is another like simple data thing. So I have data on 10 people and ask a few questions. Like in a survey, we have a few variables for 10 people, and we are going to classify them into 2 by 2 distribution table based on alcohol abuse and employment status, right? So, and we need to calculate the probability for this entry. This entry is the people who abuse alcohol and who are not employed, right? So the idea is simple. Out of 10, there are 10 observations. Oh, excuse me. Out of 10 observations, we have to check those who satisfy yes for alcohol abuse and no for employment. And then Z are those who satisfy both. So number 1 satisfies both conditions, and number 9 satisfies both conditions. So in the end, there are only 2 people fall into this category, right? So only 2 people out of 10 are in this category, so the probability is 20%. The answer is 20%. Okay, so this is it. This is the end of the quiz 1. But let me just try, and I'll just choose random numbers and see what happens, just to show you in case if you do not know how to do it. So I'm choosing random answers, and then when you submit your answer, you can see that answers are submitted. But I just realized that I did not choose any answer for question 2. So go back and save now. Okay, all saved, and I'll submit. So when you submit a quiz, you have another chance to go back and submit again. Then you can see your score. In this attempt, I chose 2 answers correct. In 2 questions, I chose correct answers. So, and you can see that whether you are wrong or not. So, like there are some for some questions, I prepared feedback, like this. Of course, and then when you are done, you may want to try again. So you can see 2 attempts. In the previous attempt, I got 1 point out of 10, and in this attempt, I got 2 points out of 10. And so my final grade, my overall grade is 2 out of 10, which is the highest one. So even if you try again and you got 0, that won't affect your overall grade. So I encourage you to try again until you get the satisfactory score. And if you want to try again, of course, you can go to quiz again or content and do it again, right? So you can start quiz again, then you can get better grades. So that is how we are going to do this in this course, and all the following quizzes up to number 12 will have the same structure. Okay. Good luck with your first quiz, and let me know if you have any questions. And I'm worried about some potential like errors during the conversion from Blackboard. So please report me any errors, and I expect none, but there can be some. So thank you for watching, and see you next week in chapter 2. Bye.